Okay, so let's take a look at 1.1, relations and functions. A function is a special type of relation. A function is a set of ordered pairs for which every value of x there is only one value of y. So for every x value, there can only be one y value. Or for every x value, there can only be one height. So let's take a look at example 1. And example 1 speaks about determining whether the following relationships are functions. Okay, so everything's a relationship, but we have to understand if the relationship is also a function. A function is a very special type of relationship where for every x value, there's only one y value. So if I take a look at the first one, and this is giving me 4 points in set notation, that's what those squiggly lines are. So this is a set of 4 points. Now these 4 points could be written on a table of values if you wish, x, y, and the first point is 1, 5, if you see this better, and the next point is 2, 6, the next point is 3, 7, and the last point is 4, 8. And we are to determine whether or not this is a function or not. Now, we know that a function means that for every x value, there should only be one y value. Well, let's take a look at every x value here. Well, for when x is 1, there is only one height, and the height is 5. When x is 2, there's only one answer, and the answer is 6 for y. When x is 3, y is 7. And when x is 4, there's only one height, and the height is 8. So therefore, every x value only has one value for y, so yes, this is a function. And let's take a look at the second one here. And the second one, again, is in ordered pairs in a set. And if I take a look at each ordered pair and just write it in a table of values, the first point is 2, 7, second point is 3, 8, then I have 3, 9, and 4, 10. And if I take a look at this, and I ask myself, is this relationship a function? Again, in order to be a function, for every x value, you could only have one y value. So if I take a look at this, when x is 2, yes, you only have one answer, and the answer is 7. However, when I take a look at x being 3, when x is 3, I do not just have one answer. When x is 3, I have an answer of 8 and an answer of 9 for y. And this means that this is not a function. So no, this is not a function, because when x is 3, you have 2 different heights that this touches, or 2 different y values that this touches. So if you have a repeating x with different y values, it is not a function. For every value of x, you can only have one value of y. So this is not a function. And let's take a look at example 2. Example 2 asks us to draw a mapping diagram to represent the following relationship. So if I take a look at this relationship, again, has a set of ordered pairs, and there are 5 ordered pairs in this set. And it's asking me to first draw a mapping diagram, and after I have drawn the mapping diagram, answer the question, is this relationship a function or not? So this is the way you draw a mapping diagram. The mapping diagram has 2 compartments. The first compartment is your x compartment. And this map of your x's, or your input compartment, is here. And then you draw a map or another compartment for your y values, or your outputs. And what you're going to do is you're going to put all the values that you see that involve x inside of the input, and all my y values for my ordered pairs in my output. Again, if you're more comfortable with writing a table of values like this, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, that is fine, that's a table of values. But again, mapping diagram, all the values that touch my x's in my points go here. So all my x values, the only value I see that is x is a repeating value. It's 0, 0, 0, 0. So I don't write 0 5 times, I just write the 0 once. So that's my only value that my x touches. And then all my output values, or all my y values that this relationship touches, are 1, 2, 3, 4, and 5. And I'll write those in numerical order, which they already are in numerical order. So 1, 2, 3, 4, 5. And then the mapping diagram goes like this. I'm going to draw each individual point with this mapping diagram. When I put the first point, 0, 1. When I plug in 0, I get an output of 1. So when I plug in 0, it gives me an output of 1. I put an arrow. From when I plug in 0, I get 1. That's my first point. My second point, 0, 2. When I plug in 0, I get 2. My third point, when I plug in 0, I get 3. My fourth point, when I plug in 0, I get 4. And my last point, 0, 5, when I plug in 0, I get 5. And that is what a mapping diagram looks like. Of course, this is one that only involves one input value, one x value, and 5 different output values. Now, looking at this mapping diagram, you should be able to tell me if this is a function or not. The answer here is no, it is not a function, because when x is 0, you have 5 different answers for y. Or when your input is 0, you have 5 different outputs. And you cannot have 5 different outputs. For every value of x, you can only have one value for y in order for the relationship to be a function. So I'd like to add another mapping diagram example to example 2 to get us more familiar with the mapping diagrams. So we'll call this example 2 double I. And let's say it asks us to draw a mapping diagram of the following points, but maybe the following points are in a table of values. And you have the point 1, 2, 3, 7, 4, 3, 5, 7, and 6, 8. And it asks you to draw a mapping diagram of these points here. Again, mapping diagram, you have one compartment or container for your x values, or your input values. The second container is for your y values, or your output values. And you list all of your x values in your input diagram here. So my x values are 1, 3, 4, 5, and 6. I'll list them in numerical order, which they are already in. And so those are the numbers that my x values touch. And then if I list the outputs, all my y values that my y values touch here, in the correct order, I'm going to list, I have 2, 7, 3, 7, and 8. But I'll list them in numerical order. So 2, then 3, then 7. I will not write the 7 twice, just once. And then the 8. So you don't write the duplicates twice. And so here are my input values and my output values. Now, in order to draw a mapping diagram for every point, I have to map out every point here. My first point, when I plug in x, I get an output of 2. So I plug in x and I get an output of 2. So it's an arrow drawing 1 that gives me an output of 2. My second point is 3, 7. So when my input is 3, my y value or my output is 7. So when my x is 3, y is 7. And then when my x is 4, y is 3. So again, 4 points to 3. And then I have the point 5, 7. So input is 5, gives me an output of 7. And then 6 gives me an output of 8. And then it asks me if this is a function. And some of you may say, well, I'm not sure. See, my x being 3 and my x being 5 both point to the same number. But that's okay, because if you look at the definition of a function, it is a relationship in which every value of x, it can only point to one value of y. And when x is 1, it only points to one output value, which is 2. When x is 3, it only points to one output value, which is 7. When x is 4, it only points to 3. When x is 5, yes, it does point to the same output value, but when x is 5, it only points to one output value being the same as 3, but that's okay. You cannot have a duplicate x pointing to two different y values, but it is okay for two different x's to point to the same y value, because that follows the rules. Again, for every value of x, you can only have one value for y. So yes, this is a function. And so let's go back to our lesson here, and if I take a look at example 3, just before example 3 it says, another way to determine if a given relation is a function is by using the vertical line test. So the vertical line test is this: if any vertical line intersects the graph of a relation more than once, then the relation is not a function. So if I can draw a vertical line on my diagram, on my picture, my graph, and it passes through the graph more than once, it is not a function. If I cannot do that, then it's okay, it is a function. So for instance, question A, determine if each relation is a function. Well, if I draw a vertical line anywhere on this function, doesn't matter where, but if I draw a vertical line right here, it will only pass through one point of the parabola. It doesn't matter if I draw it here, it will only pass through one point of the parabola. It doesn't matter where I draw a vertical line, it will only pass through one point of the parabola, so therefore, yes, this is a function. And we knew that because parabolas are all functions. So, then taking a look at this one here, this may look like a parabola, but parabolas only open up and down. This parabolic shape opens to the left, and we will learn later on how to come up with equations of these types of relationships. But if you take a look at this relationship is not a function, because if you draw a vertical line, for instance right there, you end up having it pass through two different points of this graph. And if you can draw a vertical line that passes through more than one point, so in this case 2 points, it is not a function, so no. And it should make sense to you, because if you take a look at this in terms of points, and what we've been dealing with in example 1 and example 2, when x is -4, which is where I drew my vertical line, when x is -4, it passes through the y value of 2. But also, when x is -4, it passes through the y value of -2. And again, when you take a look at the definition of a function, for every value of x, you can only have one value of y. Well, it doesn't pass the vertical line test, which means that when x is -4, you have two different outputs for y. So no, it is not a function. And that is why the vertical line test will tell you whether something is a function or not.
Yeah, a function is an x equals 1y. Okay, yeah. Student, there's no need to feel down. I said student, pick yourself off the ground. I said student, cause you're in a new unit. There's no need to be unhappy. Yeah, student, there's some things you should know. I said student, when your grades are real low, you can sing this in. I'm sure you will find many things will come to your mind. A function is an x equals 1y. A function is an x equals 1y. They have every x with only one y. You can remember if you try. Yeah, a function is an x equals 1y. A function is an x equals 1y. You can get yourself an A, you can have a good year, you can give your parents a thrill. Domain input, x values you have. I said domain input, x values you have. I said domain input, x values you have. But you got to know this one thing. Range output, y values you find. I said range output, y values you find. Range output, y values you find. I'm sure you can get this today. Yeah, a function is an x equals 1y. A function is an x equals 1y. They have every x with only one y. You can remember if you try. Yeah, a function is an x equals 1y. A function is an x equals 1y. You can get yourself an A, you can have a good year, you can give your parents it's a thrill. A function is an x equals 1y. A function is an x equals 1y. Domain input x values you have, and range output y values you find. A function is an x equals 1y. A function is an x equals 1y. Domain input x values you have, and range output y values you find.